Okay, this will begin our section 3.3 video. Section 3.3 video, part 3. I was wrong a while ago, or in the previous video. So this is section 3.3 video, part 3. Okay, I told you in this section what we're going to do is we're going to continue graphing linear equations with two variables, which is a straight line, by picking points. What we're going to do in this section, a part of this section, is we're going to look at graphing linear equations, but we're going to do it by following a specific set of instructions. So, pause the video. You don't have to draw this graph, but pause the video and write these instructions right here down, but don't draw the graph. Okay, now let's talk about this for just a second. Before we actually get to a problem, I mentioned this to you before, but let me talk about it now again. I mentioned this to you in section 3.1 video part 1, and it was this. Whenever you have if you're talking about a straight line, the point at where that graph crosses the x-axis, that point right there, we give it a special name called the x-intercept. And I told you in section 3.1 that every x-intercept, every point on the x-axis has something in common, and it's this. The second number is 0. Now, this place where the graph crosses the y-axis, that is called the y-intercept. So that point is on the y-axis. Now, every point that's located on the y-axis has something in common, and it's this. The first number is x. So, simply put, here it is. If you want to find where a graph crosses the x-axis, what we're going to do is choose y to be 0 and find the x. If you want to find where a graph crosses the y-axis, we're going to choose x to be 0 and find the y. So you're still really choosing. You're just choosing 0 for x and finding y, 0 for y and finding x. And that will tell you where your two intercepts are. Okay, so you wrote the instructions down a while ago. It says graph by using the intercepts, and you have a few in your homework like this. So let's look at this particular problem right here. 2x plus 3y equals 212. Linear equation, 2 letters. All right, so now I'm not going to pick 1 or 2 or -1 or -2 because I have to follow the instructions. It says find the two intercepts. So I'm going to abbreviate xi for the x-intercept, and I'm going to abbreviate yi for the y-intercept. All right, so let's do this. How do we find the x-intercept? What we're going to do is we're going to choose y to be 0. Now, here's the good thing about this. Most of the time, you can do these in your head without actually having to plug the number in. So, let's plug 0 in for y. If I plug 0 in for y, what's 3 times 0? It's gone. It's nothing. So, look at what you're left with. 2x equals 12. How do you get rid of the coefficient? Divide by 2. Whatever you do to one side, you have to do to the other. So if you divide both sides by 2, what do you get x to be? You get it to be 6. Now, let's find the y-intercept. Let x be 0. So to let x be 0, you take 0, plug it in for x right here. 2 times 0 is 0. So you're left with 3y equal 12. Divide both sides by 3 to get y to be 4. And then all you do is plot the point 60. You don't have to graph this if you're okay with graphing it. But 60 will be right there. 0,4 will be right there. Now make sure you put them in the right spot. And then draw your line through those 2 points. Now you say, oh my gosh, that's a lot quicker than picking some other numbers. Why don't we just do that every single time? You can. The reason we don't do it every single time is, remember, the computer does not have the ability to be able to plot fractions. So for instance, let me slide this down where I can reach it and I'll show you. Suppose this right here had been a 5 right here. All right, let y be 0. If y is 0, 3 times 0 is 0, it's gone. If this is a 5, you have to divide by 5. So you'd end up with 12 over 5. Now, is that wrong? No, it's not. So 12 over 5 would be correct. And if you could plot that on the computer, it would be correct. The problem is the computer doesn't have the ability to graph 12 over 5. And 12 over 5, by the way, is 2 2/5. So it'd be somewhere between 2 and 3. But the computer won't allow you to do that. That's why we don't do all of them by finding the intercepts. So in the ones where he says graph by using the intercepts, you must do it this way. But also, when he tells you to graph by using the intercepts, you are guaranteed that those are going to end up being whole numbers. Otherwise, he would not give them to you. Okay, so let's do another one. One more example by doing the intercepts. So let's do this one. (3x minus y equals -3. Let's do the x-intercept, and we'll do the y-intercept. Now, if the instructions doesn't tell you how to graph it, you can do this every time. I'm fine with that. You just have to follow the instructions and make sure you're doing it the way that you're asked to do it. All right, so let's see. If I want to find the x-intercept, how do we do that? We let y be 0. Now, you have to remember that. You have to remember to find the x-intercept, this is what you have to do. Okay, if I let y be 0, that goes out. So look at what you're left with. 3x equal -3. Divide both sides by 3. And when you divide both sides by 3, you get -3 over 3, which is -1. Now, how do I find the y-intercept? You let x be 0. If I let x be 0, 3 times 0 is 0. So you have -y equals -3. Divide both sides by the -1, and you get y to be a +3. And then all you do is you plot those two ordered pairs. -1, 0 would be to the left 1 and stay there. That's on your x-axis. That's why it's called the x-intercept. And then 0, 3 would be none left or right, up 3. So that's on your y-axis. That's why it's called the y-intercept. You plot those two individual points and then draw your line. So -1, 0. -1, 0 would be right there. And then 0, 3 would be right there. And then you draw your line. Now, we will look at one more way on how to graph a line in a couple of sections from now. Another way of graphing a line other than using the intercepts. But we're not ready to discuss that right now. So the main thing is you need to know that if it's a linear equation, if it has an x and a y in it, and we can graph that straight line by either choosing points, pick any number you want to for x and find y, pick any number you want to for y and find x, or you can graph it by using the intercepts. Those are the two ways to graph that line. Okay, now, still in this same section, if you will remember, I told you when we started this, I told you that a linear equation in two variables is an equation that has two letters in it. But if you remember, I said this: if one of the letters is missing, it's still a linear equation. If one of the letters is missing, it's still a linear equation. So, what I want to do is, I want to show you if one of the letters is missing, if it's still a linear equation, what is the first four letters in the word linear spell? Line. So, if I have this, 3x plus 2y equals 7. This is a linear equation. This is what we call the standard form. For a linear equation. Now, standard form just simply means this: the x and y is on one side and the numbers on the other. So this is a linear equation with two variables. Now, is this a linear equation in two variables? Yes, it is. It's not in standard form because the x is over here. Now you say, well, couldn't we put it in standard form? Yes, all you'd have to do is subtract 5x from both sides, and you put the 5x over here, it would be in standard form. But it's still a linear equation. So both of those are linear equations. Now, look at these two. Both of these are linear equations also. Remember, linear means x and y both to the first power. The difference is both of these are linear equations in one letter, not two. So if these are linear equations, if I graph them, are they lines? Yes. But they are special types of lines. So if one of your letters is missing, the graph is still a line, but it's a special type. Now, let me give you a note. Let me see if I have this right here. I'm going past it. Let me just give it to you this way. Okay, so if you noticed all of the equations that we looked at earlier, every one of the ones that we've done, all of the lines that we've looked at have been slanted, either slanted up or slanted down. Now, are all lines slanted up or slanted down? No. What if it's a horizontal line? That's perfectly flat. It's not slanted. What if it's a vertical line? That's not slanted. Now, have any of the problems we've graphed so far been vertical or horizontal lines? No. It turns out that these two equations right here, one of these lines is vertical, one of these lines is horizontal. Now, let me go ahead and tell you, I'm going to show you why in just a minute, but let me go ahead and show you how you can tell. If you have a linear equation and it has two letters in it, the x and the y, like all the ones we've been doing, those two, that when you graph that, it is always a slanted line. It's either slanted uphill or it's slanted downhill. But if one of the letters is missing and you only have one letter present, that is when it's either going to be a vertical line or a horizontal line. Now, let me tell you which one is which. I will explain it later. And you'll definitely want to write this down. If your linear equation has just an x in it, you're going to see that that's a vertical line. that means that graph looks just like this. If it has just a y in it, that's a horizontal line. That's flat. But if it has an x and a y in it, it's going to be slanted. Okay, so you can pause that if you need to. Now, so let me slide right here then again. Look at these. Linear equation, 2 variables, slanted line. Linear equation, 2 variables, slanted line. Linear equation, 1 variable, vertical line, because this has just an x in it. This is a linear equation, 1 variable. This is a horizontal line. So these are your 2 special cases for graphing a linear equation, is your vertical and your horizontal lines. These right here, this one right here and this one right here, both of those are your slanted lines. All right, and again, I'll explain why in just a minute, why this one is vertical and why this one's horizontal. Before I explain why, let me caution you about something. If it has just an x in it, what did we say the line looks like? It's vertical. Why do students sometimes get that backwards or get it confused? Because which way does your x-axis run? It runs this way. But which way does the graph of just an x run? It runs this way. So if you are not careful, you're going to think about the x-axis and y-axis. It doesn't work that way. As a matter of fact, it's just the opposite. So, now again, I'm going to show you, when we get to the graphs, I'm going to show you why they work that way. But what you need to remember is linear equation, just a x. Linear equation, just a y. Linear equation, x and a y, it's either this or it's that. Okay, so what we're going to do is in our next video, and I may start it actually, is we're going to graph. We've already graphed the slanted lines by using the intercepts. We're going to graph some lines that are just vertical or that are just horizontal. We'll do that in our next video, and that will conclude our section 3.3. So section 3.3 actually has 4 parts to it, but the next video will not be as long.